Welcome back to our flipped chemistry classroom, where today we're going to be talking about limiting reactants or limiting reagents. So we've been talking through stoichiometry and understanding how much of a product can be made or how much of a reactant is needed in order for a reaction to happen. And so today we're going to talk about the idea of a limiting reactant. So a limiting reactant is just the reactant that gets consumed first, that gets used up. And so we can only make a limited amount of product because we run out of one of the reactants. So in our example here, we have carbon, those are the little gray circles. We have oxygen, these are the little blue pairs. And they're going to come together and they're going to form carbon dioxide. And you can see here in our illustration that when the reaction is complete, we have some carbon left over. And there's just not enough oxygen left to react with those two carbon atoms. And so in this case, we ran out of oxygen. And so we would say that oxygen is our limiting reactant. If we go back to our previous image here, this looks like water. So we have some oxygen and we have some hydrogen. And you can see that here we still have some hydrogen left over and we have water molecules. And so since we have hydrogen left over, oxygen was the thing we ran out of. Oxygen would be the limiting reagent. So just a quick reminder of our problem-solving steps, because we're going to be continuing to do stoichiometry and to solve problems. So we're going to identify our given, we're going to identify our unknown, we're going to identify the equations or conversion factors that are needed. We're going to set it up and we're going to solve it and check sig fig. So as always, when we're solving a problem, we're going to guess. Now we do have a specific sequence for determining limiting reactant. So just like any other stoichiometry problem, the very first thing we're going to do is write our balanced chemical equation. Now, unlike other stoichiometry problems, with limiting reactant problems, we're going to have two givens. So we're going to be given both of our reactants. We're going to be given amounts of both of our reactants, and we're trying to figure out which one we're going to run out of first. So the very first thing we have to do is convert both of our reactants to moles. And so if we're given grams, we'll use molar mass. Atoms or molecules, we'll use Avogadro's number. Or volume, we'd use 22.4 liters. So we're going to first convert both of our reactants to moles, and then we have a choice. So some people are going to prefer to determine how much, to pick one of the reactants and determine how much of the other reactant you would need to fully consume all of that reactant. So if we go back to our picture here and we pick oxygen, so we can see that we have two molecules of oxygen. And because we know that for every one molecule of oxygen, we need 2 moles of hydrogen, we would say that for 2 moles of oxygen, we would need 4 moles or molecules of hydrogen. And so we can see that we have 6 molecules of hydrogen. And so we have more than enough hydrogen, and oxygen would be limiting. So that's one of our choices, to determine how much of that other reactant we would need to fully consume that reactant. Or the other option would be to determine how much product each reactant will produce and compare those numbers. And whichever one, so if I took my oxygen and hydrogen example again, so I can see that I have 2 oxygen, and that would make a total of 4 water. And I can see that I have 6 hydrogen, and that would make a total of 6 waters. And so because the oxygen makes fewer, only making 4, that's my limiting reactant. So we have a couple of choices. We can either determine how much of each reactant would be needed to consume all of the other one, or we can just take our stoichiometry problem all the way to the end, figure out how much product each would make, and the one that makes less is the limiting reactant, and that's how much you can make. You can't make more, because here in my example with my hydrogen and my oxygen, I can't make 5 waters. It's not halfway in between. I certainly can't make 10. It's not the 6 plus the 4. It's whatever I can make with the thing that I have the least of. So let's look at an example problem here. So here we have 6.50 grams of aluminum reacting with 5 grams of oxygen. And we want to know which reactant is limiting. We also want to know how many grams of aluminum oxide are formed and how much of the excess reagent remains. So we have lots of different problems here. And we're going to begin by determining which reactant is limiting. And you can see that in our problem, we're given 6.50 grams of aluminum and 5.00 grams of oxygen. So when we think about our stoichiometry problem, again, we have 2 givens. So first thing we're going to do, as always, is write our balanced chemical equation. So aluminum plus oxygen yields aluminum oxide, and we're going to go back and balance our chemical equation by putting a 4 in front of the aluminum, a 3 in front of the oxygen, and a 2 in front of the aluminum oxide. So we've written our balanced chemical equation, and now we're going to convert the masses of each of the reactants to moles. And since we have mass, we're going to use molar mass, 6.5 grams of aluminum. And there's, for every 1 mole of aluminum, whoops, my numbers are a little out of order here. We have 26.98 grams of aluminum, and that gives me 0.241 moles of aluminum. I'm going to do the same process for oxygen, recognizing that oxygen is diatomic. So I need to make sure that I double the molar mass of monatomic oxygen to get the mass of oxygen. And that gives me 0.156 moles of oxygen. Now, I can't simply look at these and say, well, I have less oxygen than I have aluminum, because I also need to take into consideration those coefficients on the aluminum and the oxygen. And so what I'm going to do next is I'm going to determine the quantity of one reactant that would be needed to fully consume the other reactant. So we're going to go through this process, and instead of converting to product, like we sometimes do with our stoichiometry problems, we're going to convert to moles of oxygen. And when I do that, I get that I need 0.181 moles of oxygen. And we've done this part of the problem already, and we can see that we only have 0.156 moles of oxygen. And so since I don't have enough oxygen to use up all of my aluminum, oxygen is my limiting reactant. So that's choice 1, determine the quantity of one reactant needed to fully consume the other one. In order to fully use up all of my aluminum, I would need 0.181 moles of oxygen, and I only have 0.156, so oxygen's limiting. The other approach is to do the full stoichiometry problem and calculate all the way through to figure out how much product each of them could potentially make. And so typical stoichiometry process from grams to moles, moles of aluminum to moles of aluminum oxide, and then moles to grams. And this gives me 12.3 grams of aluminum oxide. I'm going to repeat the process beginning with the oxygen, and we're going to find that we can only make 10.6 grams of aluminum oxide. So this piece of information allows me to answer 2 questions. So doing it this way allows me to answer 2 questions at once. My limiting reactant or limiting reagent is oxygen, because that's the one that the stoichiometry says makes less aluminum oxide. And so I know that oxygen is limiting, and I've also answered the question, how many grams of aluminum oxide are formed? And I can say that 10.6 grams of aluminum oxide are formed. Remember, however much this says it can make, we can't do, because we're going to run out of oxygen before we can make this much aluminum oxide. Now we have one more question. It asks us how much of the excess reagent remains. So we want to calculate the excess reagent. We know aluminum is in excess. We know we've made 10.6 grams of aluminum oxide. So how do we determine the excess reactant? I'm going to determine how much of that reactant was used up. I'm going to subtract that from the moles that were available, and I'm going to convert to mass or volume as needed. So I am going to start with my moles of oxygen. I'm going to convert to moles of aluminum, and I'm going to find that I will use 0.208 moles of aluminum. Now I'm going to convert my grams of aluminum to moles of aluminum. We've done this once already, but that's okay. And I'm going to find that we have 0.241 moles of aluminum. If I have 0.241 and I'm only going to use 0.208, then I have 0.033 moles remaining. And now I'm just going to convert that back to mass, and I'm going to find that I will have 0.890 grams of aluminum left over. And that's it for limiting reactant. So as always, I look forward to seeing you in class. If you have any questions, let me know, and I will see you soon.